Okay, so for example, let's say if we wanted to evaluate, let's say for problem A, say log of 1,000. Say for problem B, log of 1 over 100. Say for problem C, log of 10. And let's say for problem D, log of negative 10. And let's say for problem E, log of 1. Okay, so for A, we just know that log of 1,000 is the same as log base 10 of 1,000, which will make equal y. Okay, remember, whenever they don't have an equal, just make it equal to y. Okay, so that means your base to the power of y equals 1,000. So 10 to the power of y equals 1,000. Okay, so we know 10 times 10 times 10 times, 10 times 10 times 10 is 1,000. Okay, so since 10 times 10 times 10 equals 1,000, straighten that up a little bit. Confused me because I thought I wrote a 4 for a second. There we go. That means y would have to equal 3. All right. Any questions on that one? Okay. So let's say for problem B, log of 1 over 100, just going to rewrite that as log of base 10 of 1 over 100. Make that a little bit higher there. Oops. Equals y. Okay, and that gives us 10 to the power of y equals 1 over 100. Oh, keep writing that 1. 1 over 100. Okay, so now we just have to remember ten to the negative 2 is equal to 1 over 10 squared, which is equal to 1 over 100. Okay, so that means your y would have to equal negative 2. Any questions on B? Okay, so we'll continue the other two on the next page. I'll leave that up for a few more seconds. All right. Let me write down the C and D before I put that away. C, well, C, D, and E. Log of 10. Okay, so the first thing we're going to do is rewrite that as log of base 10 of 10 equals y. Okay, that means our base to the power of y equals 10. So 10 to the power of y equals 10. Okay, so that to be the same, it would just have to be y equals 1. 10 to the power of 1 is equal to 10. Okay, so D, which is log of negative 10, I'll let you do that one. Right. So if you're actually stumped on this one, you should be, because it's undefined. Okay. So with this one, that's log base 10 of negative 10 equals y. So that's 10 to the power of y equals negative 10. Okay. And there's no y value you can plug in that would make 10 equal negative 10, at least as an exponent. If they were just multiplying, you could make it negative 1. But if you plug in negative 1, you'd have 1 over 10. If you plug in positive 1, it would just be 10. So whenever you have a negative, that's why, if you remember from the beginning, we had the definition of logarithms. Remember, x is positive. Give that a little more space. Yep, that's the reason why. Because if you have a negative value of x, it's undefined. So since there is no real value of y that will make 10 to the y equal negative 10, clean that up. The logarithm is undefined. And if you actually plug that into your calculator, you'll see it comes up as undefined. All right, any questions on that one? No, okay. And for E, which was log of 1, you just rewrite that as log base 10 of 1 equals y. Okay, so 10 to the power of y equals 1. Okay, so we know anything to the power of 0 is just going to be 1. So x to the power of 0 equals 1, which means that 10 to the power of 0 will equal 1. So we know that y has to equal 0. All right. Any questions on those? All right. I'm still writing. Okay. Okay, so now we're going to go over properties of logarithms. Okay, so the first is the product property. Which just says for all real and positive numbers, we'll call them M and N to just represent our numbers. And we know our base is not equal to 1. Log of base b of m times n equals log base b of m plus log base b of n. Okay, so let's say, for example, we wanted to write each expression as a sum of logarithms. And simplify if possible. Some you can simplify, some you won't be able to. Okay, so let's say for problem A, log base 2 of 2 times 7. Okay. Problem B, log of 100 times x. And let's say for problem C, log base 5 of 125 times y times z. Okay, so for problem A, using our product property, log base 2 of 2 times 7 just becomes log base 2 of 2 plus log base 2 of 7. Okay, so this is why they say simplify, if you can. If you look here, let's say if you make log base 2 of 2 equals y. That means 2 to the power of y equals 2. And remember, this is just 2 to the first power. So that means y would have to equal 1. So log base 2 of 2 is equal to 1. So we will actually simplify this to become 1 plus log base 2 of 7. Because you don't have anything that can say 2 to the power of y equals 7, so that one doesn't simplify. Okay, so this one actually was able to be simplified. Okay, did that make sense? All right. Okay, so we'll do the same thing for problem B. Kind of separate that a little bit. Okay, so log of 100x, we can just make that log base 10 of 100x, 100 times x. Okay, and using the product property, that's going to equal log base 10 of 10 plus log base 10 of x. So log base 10 of 10, you can actually simplify that one. Because you make log base 10 of 10 equal y, 10 to the power of y equals 10. So you know 10 is the same as 10 to the first power. Okay, so we know y is equal to 1. Let's clean that up some. Okay, so we know log base 10 of 10 is equal to 1. Yes? Oh, did I? Oh, yep, I wrote that down wrong. Sorry about that. 100. So it should be 2. Sorry about that. Writing 10 over and over and over. There we go. Let me clean that up some. All right, so that's log base 10 to 100, so 10 to the power of y equals 100. Which is a little easier because 10 squared is 100, so y is equal to 2. Thank you. Okay, so this, since this is equal to y, is equal to 2. So you have 2 plus 10 to the power of y equal x. Can't really be simplified anymore, so that stays the same. You can say log base 10 of x or log of x. Either one would work. All right, so any questions on that one? Okay. Leave that up for a few seconds and we'll finish up on the next page. Okay. So for C, that was log base 5 of 125 times y times z. Okay. So we can just make that log base 5 of 125 plus log base 5 of y plus log base 5 of z. So if you have multiple factors in there, you just have multiple terms when you convert it. Okay, so here we can actually simplify that one. Okay, so we have log base 5 of 125 equals y. Okay, so 5 to the power of y equals 125. Okay, since we know 5 times 5 times 5 is 125, 5 times 5 times 5 equals 125. We know y would have to equal 3. Okay, so we know this term here just simplifies to 3. Okay, so that gives us 3 plus log base 5 of y plus log base 5 of z. All right, any questions on that one? Yes?
So we don't plug in the y for the other y in the second log?
Oh, for this one? Well, y is just a variable we picked, but here we don't know if we could have picked just as easily r for this one. But here, y is an actual unknown value. I think that, yeah, that would give us 5 to the power of y equals y, which still couldn't be reduced. Any other questions on that one? All right. And I'll put this on another page. Make sure everyone's done writing. Yep. Okay, so now we're going to talk about the quotient rule for logarithms. Okay. So once again, for all positive real numbers, m and n, and b doesn't equal 1. Log base b of m divided by n is going to equal log base b of m minus log base b of n. Okay. So you can see when you have product, you have to add. When you have quotient, you have to subtract. Okay, so let's say, for example, if you wanted to simplify log base 4 of x over 64. Okay, so we know just using the quotient rule, log base 4 of x over 64 is going to equal log base 4 of x minus log base 4 of 64. Okay, and this one actually can be simplified. Okay, so if we make log base 4 of 64 equal y, then that means 4 to the power of y equals 64. Okay, and we know that 4 times 4 times 4 is 64. That means that y would have to equal 3. So that entire term can be simplified to just 3. Okay. That's going to be log base 4 of x minus 3. All right. Any questions on that one? Okay. Let's say, for example, if we wanted to simplify let's say log, I'll leave that, of xy over 10z. Should have had bigger parentheses in front. Okay, so this one just using the quotient rule. Log of x times y over 10z is going to equal log of x times y minus log of 10 times z. Okay. Which is true, but it's just not completely simplified. Because now once we did that, we still have two logarithms that could use the the product rule. If you remember that, that's log of m times n equals log of m plus log of n. Okay? So actually both of those can be simplified a little bit more. Okay? So that's going to equal, for those two, x and y, it's log of x plus log of y. Okay, so we're just going to separate that. Minus log of 10 times z is log of 10 plus log of z. Okay, so sometimes you have to use more than one. Sometimes when you do one, it leads right to another. All right, so we can go ahead and get rid of those parentheses, or those brackets rather, by distributing the -1. So that's log of x plus log of y minus log of 10. And remember, that's a common logarithm, so it has a base of 10. Minus log of z. Okay. So this one, we can actually rewrite it. We can simplify that one. So if we write that as log base 10 of 10 equals y, 10 to the power of y equals 10, just gives us y equals 1. Okay, so this entire term can just become 1. Okay, so I'm going to try and squeeze the final answer right underneath there. And I always feel bad because I had all that space up top and I just was all willy-nilly with it and get to the end and have to cram it. So you have log of x plus log of y. Separate that. Minus 1 minus log of z, okay, which is actually your final answer. All right, so any questions on this one? All right. Okay, anyone still writing? Nope. Nope, we're at 28. Might as well go ahead and restart it since it's going to cut off in a minute anyway.